Alright, time for the math. Easy solution. We're going to discuss more factorials today and basically look at show proof that n distinct objects can be sorted n factorial ways in a sequence. Basically, I showed factorials. I introduced them in my last video, and basically factorial, just if you refresh, if you remember, like all it is, if you have 4 prime, this just equals to 4 times 3 times 2 times 1. So basically, it goes all the way there here. It just started off from the number and multiply by 1 less than the number every single time till 1. This is just 4 times 12, 24. And 0 prime is just equal to 1 by definition. You can see my other video on that. And basically this proof, what I mean by this one, I showed my other video as well. I showed that, let's say if you had A, B, C, D, you can sort these in, well, this is 4, if you call this 1, 2, 3, 4, this would be 4 numbers here or 4 letters here. So this could be sorted in 4 factorial ways equals 24 ways. So 24 ways of sorting. And what I mean by sorting is, let's say again, if you have A, B, C, D, that's 1. If you have B, C, A, D, that's 2, and then you could do this all the way to 24. Yeah, 24 unique ways. Yeah, so now I'm gonna just show the proof for just in general. This is actually, this holds true if you have n objects. Or let's look at this one. Let's just say you have let's use numbers in this case. So then let's say you have numbers 1, 2, 3, 4, 5, 6, etc. all the way to n. So n is just a general number here, and then we want to sort these all the way out. So basically, let's write the first one. Just basically, we know 1, 2, 3, 4, 5, 6, etc. all the way to n. So that's 1. And then so what we're gonna do here, we're just gonna shift the first one, the 1, to the right. We're gonna shift right. So what I mean by this is, well, we're just gonna shift it here. So the 2 goes here, just goes 1, 3, 4, 5, 6 all the way to n. And then, so it's going to be a diagonal here. So we're going to shift again, 2, 3. This is a 1 here. So as you can see, it's a diagonal across. 4, 5, 6, etc. all the way to n. And then this one, well, we're going to keep doing this all the way down. So we're going to keep doing this all the way down. And then we're going to get, finally, we're going to get 2, 3, 4, 5, 6, etc. all the way until, well, we're going to get n. Then we're going to have 1. So in this way, because the 1's going to be on every single digit here, so this is just actually n ways, because you have 1 here, all the way to n. So there's finally here. So we're going to have, it's going to be like this 1, 1, 1, all the way to there. And this is n, so this is n ways of sorting. So this is n different ways of sorting this already. But then when we look at, let's say this first one right here, this 1, 2, 3, 4, 5, 6. So we take each one separately. Let's take this first. So we're gonna look at this subset. Let's just write subset of 1, 2, 3, 4, 5, 6, etc. all the way to n. So now we're gonna sort this one, but with fixing this one. So we'll fix this, and now we're gonna look at the 2. Now the 2 we're gonna shift right. So what we're basically doing is just finding all the different ways of sorting. Sorting this one right here where 1 is stayed at this position. Now we're gonna sort all the ones where, yeah. So that's what we're doing here. So we're just gonna shift 2 there, and then rearrange accordingly. So we're gonna have 1, 3, 2, 4, 5, 6. all the way to n. This is going to be 1, 3, 4, 2, 5, 6, all the way to n. And etc. This is going to be the same thing as here, how we sorted it. So this is it's gonna keep going down. It's going to be 1 all the way down. So we're going to get 1 here. 1, 3, 4, 5, 6, all the way until, well, n, and then we're going to have a 2. And so on. This goes all the way down here, and then this one, as you see, it's a diagonal across again, and all the way it's gonna be like 2, 2, all the way to here. But in this case, this is, if you see how many times this one's actually n minus 1 because we know that the full length of this is n, and 2 is inside every single digit space except the first one. So this is n minus 1. Whereas this one, the 1 is in every single case here. And that's why, yeah, this one is, yeah, this one's n. So this is the n ways of sorting it. Okay, so basically, so we got this one right here. And now what we could do here is take this one out again. So we're going to use this new subset. We'll just call this 2. So this one we're going to have 2, this is a subset of a subset. So we'll have basically 1, 2, 3, 4, 5, 6, all the way to n. So now what we're going to do here is fix both of these. So we're going to keep stationary these and then look at how many ways of sorting this. So this is fix. And then we're going to shift the 3 right. Hopefully you can see the pattern now. This one should be, and then we're going to see how many ways of sorting this one out while leaving these two fixed. It's going to be n minus 2 because you see the 2's there. So we shift right, so we're going to get 1, 2, 4, 3, 5, 6, all the way to n. And similarly, we're going to have a diagonal across the whole thing. And this keeps going down here. This is going to be 1, 2, 4, 5, 6, all the way to n, and then the 3. And then this one keeps going 3, 3, all the way to here. And as you can see here, this one is, again, this is n here, but then so across here is n. This one's only in every single digit except these first two. So we're gonna have, this is n minus 2 ways. So to basically recap what's going on here, so basically this is when we shifted 1 across like this, we have n ways, and then if we look at the first one here, we get a subset. So when each one of this could be sorted n minus 1 ways. Then when you look at the second one here, if you fix this and shift to the right as well, this one you'll also get the same thing, n minus 1. So if we keep doing this one, so then this subset inside here can be sorted n minus 2 ways. Then if we keep doing this, let's say if we keep doing this, repeat it until we get to the end. So repeat until basically once we get to something like this. Let's go 1, 2, 3, 4, 5, 6, all the way till, let's say this number is n minus 1, so this is the one right next to it, n here. So now let's say we fix all of these ones. Let's say fix everything here. Actually, yeah, we're going to fix this one as well, so until we get to all the way to the 1 minus n. So we fix all of these ones, and then we're just left with this one because we can't shift right. So can't shift right anymore. So then we're left with all the way until, well, this is just 1. So we do this all the way until 1. So what happens here then, if you try to wrap your head around this, is it's a number this has n terms here, and n ways of sorting it, and each one of these has n minus 1, and each one of these has n minus 2 ways, all the way until, well, the last one, whereas it just has one way of sorting it here. And if we were to take one step back here, actually, let's say we wanted to fix this side only, then we're going to be left with, well, 1, 2, 3, 4, 5, 6, all the way till n minus 1, n, and then this one, again, you would fix everything, then make this to the right, and this would be shift right. So we're going to just get 1, 2, 3, 4, 5, 6, etc. And this one's just n minus 1. And this is 2. So this is the one before this. And then this one here, if we shift this one, each one has 1. And whatnot. So if you try to wrap your head around all this one, then what this means is the first set we have n ways of sorting it, but each one of these has n minus 1. So we have to multiply by all those n minus 1 times. And then now each one of these has n minus 2. And each one of this one has, well, n minus 3, and so on, all the way until, well, 1. And this one is basically a definition of n factorial. This is all n factorial is. So then if you look at, let's say we had ex a b c d, this one there's 4. And I showed my other video, basically if you had a b c d, you do the same thing as fixing this one. We're gonna get b a c d, b c a d, b c a. So this is 4 ways. And then this one, this subset, we get, well, a b c d, and then fix this one, shift this right. So we're gonna get this is c b d, a c d b. So now we have 3 here. So 3 ways in this one, and then if we do this subset where we fix these two and shift this right, we get a b d c, and this is 2 ways. And then last one is just a b c d. These are all fixed. So fix, and this one can't do anything, so we just get 1. So basically, again, this one will have 4 times, well, every single one of these can be done like this, especially this one. If you have a c d number, we just fix this one and then shift right b. So we're gonna get, this one's gonna be c a b d, and this one's just gonna be c a d b. And the diagonal's a bit different here, but again, nonetheless, this is 3 as well. And as you see, the pattern keeps going here. So this one will have 2, and then this 2 each has 1. So we're left with, again, and then you can do this, yeah, 4 times here. So we have to do 4 times this by, well, each one has 3. So that's 12 ways there, and then each one of the 3 has 2. So we always have to do this. And then each one of the 2 has 1. This is 1. Yeah, let's just put on brackets. So then this just equals 2. 4 factorial equals 4 times 3 times 2 times 1, and equals 24. Yeah, well, let's quickly on this one. You can see other video I did this a bit slowly, but anyways, this is basically how it is. Hopefully you wrap your head around this, and then this is pretty useful in a lot of statistics and math and whatnot. This comes up a lot, yeah, especially in if you're playing poker or whatever, want to see compare odds of whatnot. This is a quick way of finding how many different ways of sorting unique, well, basically distinct objects. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.